Hello everyone. In this video you are going to learn the basic fundamental concept of chemistry, that is percentage composition. Before studying this percentage composition, let us recall the fundamental concept, that is the meaning of compound. As you all know that, how does the compounds are formed? Compounds are formed by the combination of different elements in a fixed ratio. For example, if I take sulfuric acid, that is H2SO4. So what is the ratio of atoms present in this molecule or in this compound? That is, it contains three elements, that is hydrogen, sulfur and oxygen, which are present in the ratio of 2 atoms of hydrogen is to 1 atom of sulfur is to 4 atoms of oxygen. So this is the ratio of atoms which forms this molecule, that is the sulfuric acid. That is 2 atoms of hydrogen, 1 atom of sulfur, so 4 atoms of oxygen, they makes this compound, that is sulfuric acid. But today's topic is percentage composition. Then what is this percentage composition? That is, the percentage composition of a compound is the percentage by weight of each element present in it. I will repeat again, percentage composition of a compound is the percentage by weight of each element present in it. Look at in this example again. Here we are saying percentage by weight of each element. Say, what is the atomic mass of hydrogen? So atomic mass of hydrogen is 1, right? For 1 hydrogen is 1 atomic mass, and for sulfur and for oxygen they have their respective atomic masses. Okay, now what is the percentage by the weight? For example, if you take the total molecular mass of this sulfuric acid, it will give you some mass, but that mass is produced by the addition of masses of hydrogen, sulfur and oxygen. Okay, so then it forms the 100% of the mass of that compound. Now according to this definition, we have to find percentage by weight of each element. That means out of the 100 mass, how much the mass is donated by the hydrogen, how much it is donated by the sulfur, how much mass is donated by oxygen. So if you find that, then it is said to be percentage composition. So let me make you clear in the examples. Now come to the formula. Percentage of an element in a compound is equal to total weight of the element in one molecule. Look at it again, total weight of the element in one molecule. Okay, then divided by gram molecular weight of the compound, or we'll say it as molecular mass of the compound into 100. Now shall we take an example to find it, or how to find the percentage composition of any element which is present in a compound. For example, calculate percentage composition of hydrogen in water. I will repeat it again, calculate percentage composition of hydrogen in water. But please keep this in your mind. What is the meaning of percentage composition? So percentage composition, it is the percentage by weight. Clear? It is the percentage by weight of each element present in that compound. That means we have to find how many percentage of mass of hydrogen is present in water. Now according to the formula, we have to find the numerator, that is total weight of the element in one molecule, then denominator gram molecular weight of the compound. But here we do not have those values, we have to find by using the given data. So given that relative atomic masses of hydrogen is 1 and oxygen is 16, then we'll find the molecular mass of the water first. Okay, so what is the molecular formula of water? That is H2O. Then to find the molecular mass of this molecule, we have the formula, that is number of atoms into atomic mass. Okay, so we'll use the formula as many number of times the elements present in that compound. Now, how many elements are present here? 2 elements. So we will use the same formula twice. Okay, now one time for the hydrogen and the second time for the oxygen. So number of atoms of hydrogen and atomic mass of the hydrogen. So now we have done it for hydrogen, plus we have to add it. You know why? Because these two elements are combined. Okay, that means the mass of the hydrogen and oxygen gets added up while forming molecule. So number of atoms of oxygen into atomic mass of oxygen. So now I'm using the short form, atomic mass of oxygen. Now substitute the values. Number of atoms of hydrogen which is present in this molecule. How many atoms are present here? 2 atoms into atomic mass of the hydrogen, that is according to the given data it is 1, then plus number of atoms of oxygen which is present in this molecule is 1 into atomic mass of the oxygen. So according to the given data it is 16. Now on simplifying it, we will get 2 ones are 2 plus 16 ones are 16, which is equal to 18 AMU. Then if you complete it, or if you consider it for the gram molecular mass, then on replacing AMU by G, it becomes gram molecular mass, that is 18 grams. Okay, or in terms of atomic mass unit, it is 18 AMU. Now we will consider this mass, that is the total molecular mass of the water, as how many percent? 100%. Clear? The total molecular mass of the water is 100%. Now come back to the definition of percentage composition. What is percentage composition? It is the percentage by weight of each element present in that compound. That means only hydrogen does not make 100%. Only oxygen mass does not make 100%. That is, addition of this mass of the hydrogen and mass of the oxygen together, they makes up 100%. Clear? But now what we have to find? We have to find that what is the percentage of mass of hydrogen present in this 100%. That is our problem. Now we will find how many percentage by weight hydrogen is present in this 100%. Okay, now we will use the formula, that is percentage composition of what? Percentage composition of hydrogen in water, which is equal to total weight of hydrogen. You know why I wrote it as hydrogen, H? That is symbol of hydrogen is H. According to the formula, that is total weight of the given element or any element. Which element we are finding? We are finding it for hydrogen. So I am taking the total weight of the hydrogen in that molecule. Then gram molecular mass. Gram molecular mass of water, because the example which we took here is water. into, since it is percentage, we have to multiply it by 100 equals total weight of hydrogen. Okay, I will do it once again here. H2O. Now I have to find it only for hydrogen, right? What is the total weight of hydrogen present in this molecule? That is 2, because for one atom of hydrogen, atomic mass is 1. Since it contains 2 atoms of hydrogen, it is 2 ones are 2. Okay, then 2 divided by gram molecular mass of water. Already we have found it. Gram molecular mass of the water is, it is 18 AMU into 100. So on simplifying it, what we'll get? We will get 11.1%. Okay, we'll get 11.1% of mass. 11.1% of mass of what? That is mass of hydrogen, which is present in water molecule. For example, see here, the total mass of the water is 18 AMU. That means this 18 AMU, we will consider it as how many percent? 100%. Then what is the mass percentage of this hydrogen? The mass percentage of hydrogen is 11.1%. Then now can you get the idea what is the meaning of mass or percentage composition? Now we have found it for only hydrogen. Out of this 100%, 11.1% of mass is of hydrogen. Then what about oxygen mass percentage? It is very simple. If you subtract this 11.1% by this 100, you will get what is the percentage composition of oxygen. So together the mass of the hydrogen and mass of the oxygen makes up 100%. But now we have found it for hydrogen mass percentage, which is present in the total mass of the water. This is the way how to find percentage composition. Now let us do one more example. Calculate percentage composition of carbon in sodium carbonate. I will repeat again. Calculate percentage composition of carbon. Which one? Percentage composition of carbon in sodium carbonate. What is the molecular formula of sodium carbonate? That is Na2CO3. Now in this compound we have to find the percentage composition of only carbon. Okay, so to find it we have the data that is given that the relative atomic masses of oxygen is 16, sodium is 23 and carbon is 12. So we will solve it to find percentage composition of carbon. Then we need the value of molecular mass of sodium carbonate, because we have to substitute that in the formula denominator. Now how to find molecular mass of this sodium carbonate Na2CO3? Please recall the formula which I told you earlier. Now I will not write it again, but we'll use the method, that is number of atoms into atomic mass. So we'll use the formula as many times the elements are present in that molecule. So how many elements are present in this molecule? That is sodium 1, carbon 2, oxygen 3. That means we will use 3 times. So now number of atoms of sodium present here is 2 into atomic mass of the sodium is 23, plus we have to add it for carbon. Number of atoms of carbon present in this molecule is only 1 into the total atomic mass of the carbon is 12, plus the number of atoms of oxygen present in this molecule is 3 atoms into atomic mass of the oxygen is 16, which is equal to 23 2s are 46 plus 12 ones are 12 plus 16 threes are 48. So on adding all these values, we will get 106 AMU, that is atomic mass unit. The total molecular mass of the sodium carbonate is 106 AMU. So now we will consider this mass as 100% because we have to find it in terms of percentage. Okay, now out of this 100% mass, what is the percentage by weight of carbon present in this 100%? So let me do here itself. Now I will divide the screen here. We know the formula: percentage composition of carbon in sodium carbonate Na2CO3 in sodium carbonate is equal to, just recall the formula, that is total weight of the carbon. Okay, it is the total weight of carbon because we are finding it for carbon element, divided by molecular mass, that is gram molecular mass of sodium carbonate, that is Na2CO3 into 100 equal to. So now substitute the values. What is the total weight of carbon which is present in this molecule? So you will get that here itself. Since the molecule contains only one atom and its atomic mass is 12, so 12 ones are 12. So total weight of the carbon which is present in that molecule is only 12 divided by gram molecular mass, or the molecular mass of the sodium carbonate is 106. So 106 into 100. So on simplifying it, what you will get? We will get, that is 11.3 percentage of carbon. Please keep this in your mind. So now on simplifying it, we have got 11.3% of carbon in sodium carbonate, that is Na2CO3. So if I write that here, the total molecular formula, that is Na2CO3, its molecular mass is 106 AMU. We considered it as 100%. Sorry, it is not 1000, it is 100%. And then what is the total mass percentage of the carbon? That is 11.3%. So we have not calculated it for sodium. Okay, so sodium is still question, and we have not found it for oxygen. It is also in question mark. We have found percentage composition of only carbon. So in this molecule, since the total molecular mass of the sodium carbonate is 106, that is 106 AMU, out of this 11.3% of mass is contributed by the carbon, and the remaining mass are contributed by sodium and oxygen. So now if you understand this concept, you can also find the percentage composition of sodium and also for oxygen by yourself. So please try it, and if you didn't get it, watch this video again and again and try to solve yourself by taking many examples such as magnesium chloride, or earlier that is sulfuric acid, or potassium carbonate. So any examples. So now I think you have understood this concept. If you like it, press the like button. Also subscribe to this channel to get the further updates. Thank you.